Welcome everyone. The question that is shown on the screen, came in Physics CBSE 2026 question paper. A thin plano-convex lens and a thin equi-concave lens. So this is the plano-concave lens, okay? This is the plano-concave lens of the same refractive index, and this is the equi-concave lens. Both sides are concave and having the equal radius of the both spherical surface have the same radius of curvature. So equi-concave lens are kept coaxially in contact as shown in the figure. Okay, assuming both the lenses are made up of glass and a refractive index mu, and capital R is the radius of curvature of the each of the curved surfaces. That means the plano-convex lens, okay, these one have the same radius of curvature, the spherical surface same radius of curvature. Along with that, this equi-concave lens, all the spherical surface of the same radius of curvature, and that is R. Okay, so what we have to find it out? We have to find the focal length of this combination. Okay, and four options are given. Option A equal to R divided by mu minus 1, option B equal to minus R divided by mu minus 1, and option C is equal to 2R divided by mu minus 1, and option D is minus 2R divided by mu minus 1. For this purpose, two formulas we need to know. Okay, the first formula you need to know, that is, if you want to find it out the equivalent focal length of a combination, then 1 by f equal to 1 by f1 plus 1 by f2. Okay, or rather we can write it down not small f, this is the capital F. That is the equivalent focal length of the two lenses if they are kept in contact with each other. Okay, no separation between the two lenses. Okay, and another one formula which is called the lens maker's formula, that is 1 by f equal to mu minus 1 by r1 minus of 1 by r2. Okay, so these two formulas basically required here. Now if I take the first one, that is this one. What is this? This is plano-convex lens. Plano-convex lens. So if I want to find it out, this focal length of this particular lens, then we can write down 1 by f1, that is the focal length of this lens, equal to mu minus 1 according to this formula, multiplied by 1 by, what is the first surface? The first surface is the plane 1. Since the first surface is the plane 1, okay, so we can write it down. The second surface is the and the second surface is my convex one. So I can write it down this equation as 1 by r minus of 1 by infinity. Okay, first surface, second surface, we can write down this equation. Okay, so we can say that is it is the mu minus 1. Okay, so divided by r. So 1 by f1 we have already obtained. Now is this equation, sorry, this lens, equi-convex lens. The first surface, if I say first surface is this one, the first surface is the convex one. First surface is the convex one, that means this surface. Second surface is the concave one, that means this surface. Okay, so first convex, concave. So for the first surface, that is for the r1, we can say, if I write it down, the r1 is minus r, because the first surface is the concave surface and the second surface is r2. R2 is equal to plus r. So obviously if I use this equation for this equi-concave lens, then 1 by f2 equal to mu minus 1 equal to 1 divided by minus r plus of, no, not plus of, minus of 1 divided by plus r. Okay, so if I do this, then obviously I am getting this is 2 divided by r mu minus 1. So if I add 1 by f1 and 1 by f2, so this will become 1 by capital F. The value of 1 by f1 I am placing here, that is mu minus 1 divided by r, and the value of the 1 by f2 I am placing here, that is minus of 2 by r. Okay, so this first bracket need to put there, mu minus 1. Okay, so if you do this calculation, then obviously if I take 1 by r as taken as a common, it is mu minus 1 minus of 2 mu minus 1. So from here it is 1 by r mu minus 1 minus of 2 mu plus minus minus plus, so plus of 2. Okay, so mu minus 2 mu, so we can say this is 1 by r, mu minus 2 mu is minus of mu minus 1 plus 2, so that is plus of 1. Okay, so from here obviously we can say that is it is minus of mu minus 1 divided by r. So what is that? So we can write down here, that is my 1 by capital F. I have calculated, I have get it is mu minus 1 divided by capital R. So focal length, if I want to find it out, what is the focal length, that is the inverse reciprocal of that, that is minus of capital R divided by mu minus of 1. So it is option B is the correct answer here. Thank you all of you.